All right, let's dive right into this explainer. Look, if you're working in data engineering right now, you already know the landscape has gotten overwhelmingly complex over the last few years. I mean, we're at a point where teams feel completely pressured to spin up massive distributed clusters just to query, a few gigabytes of data. It's honestly exhausting. Well, Duck Lake has recently popped up as a potential cure for all that complexity. But whenever a new tool generates this much buzz, there's always that lingering question, right? Is it actually a truly open, independent tool, or is it just a gateway drug into some commercial ecosystem? Let's unpack the facts. So that naturally brings us to the exact question developers worried about vendor lock-in are asking right now. Do I actually need MotherDuck to use Duck Lake? And hey, it's a completely fair question. When powerful new tech hits the scene, as engineers, we're basically hardwired to look for the catch. We want to know if we're going to get roped into a paid environment just to kick the tires. So let's get you a definitive answer.
Section 1, the MotherDuck question. Let's tackle the elephant in the room and separate the core tool from the commercial wrapper.
The dynamic between these two is actually super simple, but it is absolutely crucial to understand. On one side, you have Duck Lake, which is local, self-hosted, and entirely open source. On the flip side is MotherDuck, which is a cloud-managed commercial service. So the short answer to that burning question, yes, you can use Duck Lake completely, 100% independent of MotherDuck. They aren't permanently tethered together, and using one absolutely doesn't mandate using the other. Okay, so what actually is MotherDuck then? Basically, it's a commercial, cloud-managed platform that offers hosted Duck Lake database infrastructure. It's fantastic if you just want to skip managing servers, avoid configuring local environments, and deploy a seamless serverless architecture in the cloud. They handle all that tedious background management for you. But, and this is the big takeaway here, it is a premium, optional service built around the core engine. It is not a mandatory dependency to make the engine work. Moving right along to Section 2, running completely standalone. Let's see how this builds into a powerful setup on your own hardware.
It really is incredibly straightforward. Duck Lake is inherently designed from the ground up to run locally or to be self-hosted, leveraging the insanely popular open-source DuckDB query engine. We've hit this massive paradigm shift in computing where modern laptops literally have more RAM and processing power than the data center servers of 10 years ago. So whether you're querying a dataset on your laptop during a flight or spinning it up on a private server rack at the office, you've got everything you need right there.
And the way it handles metadata? Honestly, it's a massive advantage. To run Duck Lake, you obviously need a catalog to keep track of your tables, but you aren't forced into some complex proprietary box to do it. You don't have to navigate the nightmare of deploying a massive Hive metastore or spinning up a JVM just to manage your metadata. You can literally attach Duck Lake to a local DuckDB file, SQL, or even hook it straight into an existing Postgres database. It just integrates seamlessly into the lightweight infrastructure you're probably already maintaining. As for the developer experience, well, you just initialize and run it using standard SQL commands. There's no proprietary magic here, and absolutely no obscure, totally new API syntax that you have to spend weeks learning. By sticking to universally understood SQL, it keeps the barrier to entry incredibly low for any data practitioner. You can literally be up and running in minutes using the exact language you already speak natively. All right, Section 3, built by DuckDB Labs. Let's pivot and explore the open source origins driving all this tech. So the crucial point here is that Duck Lake is a fully open source table and catalog specification, and it's released under the MIT license. If you write software, you already know the MIT license is basically the absolute gold standard for open, frictionless use. It grants you the ultimate freedom to use, modify, and integrate this tool deeply into your enterprise stacks without jumping through endless legal or financial hoops. It truly belongs to the community. And importantly, it was created by DuckDB Labs. Yup, the exact same team behind DuckDB itself. This guarantees not just top-tier engineering that meshes perfectly with the underlying query engine, but a very specific open-source ethos. This team has a proven track record of championing high-performance, community-driven data tools. They actually understand what developers want to use. Which kind of brings us to the why. Like, why did they build this in the first place? Well, look at the current landscape of table formats. We have massive names out there like Apache Iceberg and Delta Lake. They're incredibly powerful, sure, but let's be honest, they are notoriously heavyweight. They often require complex distributed environments, Spark clusters, and heavy JVM dependencies just to operate at all.
Duck Lake was explicitly created to be the antidote to that. It's a refreshingly open, lightweight, and nimble alternative, completely unburdened by enterprise complexity. It gives you the agility of a single node architecture when that is exactly what the job requires. Section 4, Zero Vendor Lock-in. Let's piece all these architectural choices together to see how they guarantee your ultimate control. It all starts with the brain of your data lake, the metadata. Because your catalog resides in standard relational databases like SQLite or Postgres, you physically hold the keys. You aren't trusting your core table schemas to some black box SAS format owned by a massive cloud provider. You can literally just open the file and look at the schema yourself. Now, add standard Apache Parquet files to that equation. Your actual analytical data isn't locked away in a proprietary format either. It's stored as highly optimized standard Parquet. And you have total authority over where those bytes live, whether that's sitting on a local hard drive for a quick weekend project or up in an S3 bucket with your preferred cloud provider. So Open SQL metadata combined with Open Parquet data files equals absolute data ownership. Literally zero vendor lock-in. If you decide a year from now that you want to migrate your data or use an entirely different query engine to read it, you totally can. You aren't trapped in an ecosystem. You own the metadata, you own the storage, and the bridge between them is fully open source. So I'll leave you with this question to ponder. With absolutely no vendor lock-in and total local control, what will you build with your data? We are officially stepping into an era where you no longer need a massive, complex, distributed computing cluster just to query your own data lake. That barrier to entry has been fundamentally shattered. You have the freedom, you have the open source tools, and the independence running right there on your local machine. So what's your next big data project going to be?